Okay. So with convolution, let's say, for example, when you have two signals. Right now, we just look at the mathematical aspect of this. You know, it may have some kind of application in digital signal processing. Let's say when you have two signals, xn, and then hn, for example, the convolution evaluate the discrete time convolution. Let's call the output yn is x of n convolved with so this is the symbol for convolution. It's an asterisk sign, not a star. Don't put anything like cross, or don't use a star or something like this. You know, it's a convolution sign. It's asterisk. This convolution is a sum of xk. What we do is we usually change the variable from n to k. When we do the example, you'll see. On one of the signals, we change the variable from n to k. On the other signal, we replace the n with n minus k. Or it can be the other way around also. And still the pink is coming out. For example, for k is from negative infinity to positive infinity. Or it can be the other way around also. It can be n minus k asterisk convolved with h k. It can be either you can replace the n in the x signal with k and the other one with n minus k, or you can replace the n in the n in the x signal with n minus k, and the other one with just k. So both are the same thing. Now let's look at an example. We're given two signals xk, x of n is un minus un minus 8. And there's another signal U n minus S. Another signal Hn is 1/4 multiplied by Un So we have two signals here. The first thing we want to do is change variables. Okay, on one signal, in the signal you let n equals to k. So therefore xk becomes uk minus u k minus 8. And that's one signal. On the other signal, you replace the n with n minus k. So therefore h, replace the n with n minus k, 1/4 u n minus k minus, there's not enough space here. Let me make this slightly smaller. Okay. Minus u n minus k k minus, sorry, minus u n minus k n minus k minus 5. Okay. After doing that, we're going to plot these signals. So let's plot xk first. Xk plot xk signals signals start at k equal to 0. Okay, after that it's going to be just 0. So you guys should know how to plot this. If you don't know how to plot this, then you have to go step by step. First, you have to plot use of k. You know, you have to plot your use of k. For example, you plot use of k, and then you subtract that from use of k minus 8. You know, that's it starts from 8, 9, 10, 11. So when you subtract them, the signal at 8 will disappear, will go to 0. So if you're going to draw a signal here, you're wrong, okay? So you should know this. These are the basic things we already discussed in length yesterday. I should have reviewed this before coming to this class. So this is x of k. You guys follow?
So x of k, right?
Okay, x of k, thanks. Then x, next you plot x, h n minus k. By the way, the amplitude here is 1. And if you look at, in order to plot h n minus k, you may want to plot step by step. Probably you have the two ways of doing things. I already showed you yesterday, but it's up to you how you want to do it. Right. Remember, you can always plot. Remember how you plotted. First, you may want to plot h minus k. Okay, h minus k is a signal that's going this way. The signal amplitude is 1/4 h minus k. So this signal goes on to infinity, negative infinity. Okay. So if you plus n, remember last time when you plus n, right now what will happen is now when you plus n, I can show you. Maybe we'll do another step here. Okay, 0, -1, -2, -3, -4. Now you're going to have h n minus k is same as minus k plus n, right? So do you remember what you do usually when you have to add n? you have to go and add okay, let me write this. 0, -1, -2, -3, -4. So now you have plus n. All you have to do is just plus n, plus n, plus n, plus n, plus n. So when you plus n, what will happen is it's going to be n minus 4, n minus 3, n minus 2, n minus 1, n minus 0 is just n. N can be anything. We don't know what n is. So you cannot tell where exactly the signal is right now. Okay, that is n minus k. The convolution sum yn is equals to the summation of k is equals to minus infinity. So now we already change everything to k. So this has to be k. This has to be k. Okay, one signal, this signal also must be k. Okay, one signal you change variable, you change the variable to k. This signal you change the variable to k. Change variable to k. In this one, what you did, you inverse the signal, inversed and shifted. Inversed and shifted by n. So you have done some operation on the signals. Now you're going to do the convolution sum. The convolution sum is a summation of k from minus infinity to positive infinity, x n minus k, hk. It's also same as xk h n minus k. In our example, we're going to use this. In our example, we are using this. Both will give same result. So now you have the signals plotted. Now what you're going to do is you're going to slide h n minus k through x of k to convolve. So I'm going to use this formula, same formula, but I'm going to use the one in green, highlighted in green. Okay, are we still there?
Yes, sir.
Sir.
Uh-huh.
Yes, sir.
Sir, can you scroll up
Okay.
a bit more for the his bracket and okay. Why we don't substitute minus the u bracket n minus k minus 5 over there, the behind part? Have we done that yet?
Oh, yeah, you mean n
Minus k minus 5. Have we done that? No, am I right?
Oh, yes, we have done that. Yeah, right here. There.
And how about the minus 5? It's not included.
-5 will remain there because -5 is just a constant number. It's just a number. We only replace the n with n minus k. We only replace the n with n minus k. See the n, we're only replacing the n with n minus k. Here we are replacing the n with the k.
Okay, sir.
Okay. Anybody has any question?
No, sir.
No, sir.
Okay.
No, sir.
Anybody hear double voice like yesterday?
No more.
Anybody? Huh? Yesterday I had
More
a tough
already.
time editing the video. I had a tough time editing the video because the people ask question once and then it echo again second time. So I have to remove all that and uploaded the video. So what we're going to do, the way we do convolution here, we're doing it graphically. You're going to slide, you're going to fix, you're going to just put the xk, fix it, and then what you're going to do, you're going to slide, you're going to do this. You're going to like come here. Okay, at this point, you can see at this point, what you can note, you note that this, the first signal here, before sliding through, and this signal here, they are not overlapped yet, okay? There's no overlap yet. Okay. When n becomes 0, they overlap, right?
Yes.
Is 0. If n is 0, let's say if I put, if this n becomes 0, when n is 0, then you move in. That means you overlap like this, okay? When n is 0, isn't it? Agree? When n equal to 0, there's a 0 signal here at xk, and that's n is 0 at h minus k plus n. Then there's two signals overlap. Overlap means you have signal at n at k is equal to 0.
So if the amplitude is different, how will be the outcome?
We talk
Like,
about that later.
yeah,
Okay.
okay.
Now I'm talking about overlapping only. Overlapping. Do you understand what I mean by overlap?
Yeah. Okay, sir.
Overlap means you have signal at n equal to 0. There's a signal here. That means you have 1 year, for example, at n equal to 0, and you have 1/4 year at n equal to 0. Then you can multiply them, right? Like, for example, in this case, you can multiply them, isn't it? Okay, you get a result, right?
Yes.
But when it is not, when it's not overlapped, okay, when it is not overlapped at n equal to when it's not overlapped, when when k equal to 0. So this is when k equal to 0. You have zeros. There's nothing here, 0, but you have a signal of 1 there. So 1 times 0 is 0, isn't it? So that means I can say when n is equals to less than 0, the output yn is equal to 0. So this means this is same as when k is less than 0. K is less than 0, the output is 0 because there's no signal. There's no signal here, zero signal. 0 times 1 is going to be 0. Do you guys see that clearly?
Yes, sir.
Okay. So the next case is you continue to slide it through. Let me copy this. So I'm just I'm going to do this in detail for once. The next time, you don't really have to draw them over and over again. N is less than 0. This is the first scenario when n is less than 0, output is 0. Because there's no overlap. For n is equal to less than 0, then yn, y sub n output is 0. Output. Okay, the next one, then you slowly start to slide in. Let's say now you're sliding in. Okay, now when you slide in, you overlap n. You're already overlapping the first signal at k equals 0. Now you keep moving. Now you overlap two signals at k equal to 0 and 1. Now you move and you move and then keep moving until all of them are overlapped. What is this? Okay. So now you see all of them are overlapped. So here, what is the range of n? N is greater than 0. N is greater than 0. But less than what? N is greater than 0, but less than? What is limiting the upper limit of n?
4, sir.
Huh? 4.
4, 4.
Okay. Yes. The upper limit, you can see the lower limit is 0, right? And the upper limit is 4. Because this is where the overlapping, right? See right here and right here. Okay, 0 to 4. Zero to 4. K is, so in this case, what is K? K is less than, K is limited by what? K is limited by n, right or not? We don't know what is the value of n. Okay, n can be anything. If n is, for example, in this case, if n is 4, then it's going to be, n is going to be 4, then you're going to be aligned like the way you are right now. So if n is 4, then you're going to be having this. If n is 5, then you're going to have 5 here. Okay, if n is infinity, then you're going to have, okay, if you cannot have n infinity because the upper limit is limited by 7 here. After 7, everything goes to 0, right? After 7, everything goes to 0. But n, so the upper limit in this case for now is determined by n, maybe a finite value of n. The maximum n can have is 7, I think. So you guys see, look at this and tell me if you understand why n is from 0 to 4 and k is from 0 to n. For k, the lower limit is determined by here, 0, because up below 0, there's no signals. So the upper limit is determined by this n. This is k axis, you know, k. Okay, is this clear? Sojin, please look at this carefully.
Yeah. Yeah.
As we are flowing, you know, you should ask questions so that it'll be easier. Anybody? Any question?
No, sir, clear.
Okay, next what we do. So therefore now you go ahead. Since we have overlap now, we're going to have an output, right? So the output is using this formula here, using this summation formula, k is minus infinity summation from k. K is equals to minus infinity to positive infinity But in this case, our lower limit what is our lower limit? K is equal to
0.
0. Upper
To
limit
4.
n.
N.
This one, okay, n. So we don't know n. How are we going to evaluate this? So it's going to be hk, sorry, xk, h, n minus k. So to evaluate this, you have to, the upper limit is n. So what this is telling you, this is you are summing two signals, your product of two signals. One of the signal is inverse and shifted, summing the product of two signals. So upper limit minus lower limit plus 1. Upper limit, lower limit. But don't forget here, the signal amplitude, one of them is 1, isn't it? So the other one is 1/4. So don't forget the amplitude. The amplitude of hk is 1, but the amplitude of h minus k plus n is 1/4. So it's going to be 1/4 multiplied by upper limit minus lower limit plus 1. So that's going to give you, so n is going to be, n is going to be the inclusive. N is going to be less than or equal to 4. Greater or equal to 0.
Sir,
Huh?
can you
Yes.
explain again? I don't get it on this part.
Which part?
This yn equal to bracket 1, then we get the answer 1/4 bracket n plus 1. I don't get it. Why are you getting this answer?
Okay, this is the amplitude xn. This is the xk, right? Isn't it? You are multiplying two signal. So the amplitude is 1, isn't it? Yeah.
Yeah, got it.
That's why 1 here. So the amplitude of our signal is 1/4. And that's why you have the 1/4 here.
Okay.
Amplitude.
So why we putting the bracket inside is n minus 0 plus 1?
Or this,
Yeah.
if you don't upper limit minus lower limit, you know, right? Okay, let's say if I take the signal apart here, sorry. Okay, just take the overlapping part. You take the overlapping part, and then if you look at it, okay, now you can see clearly, if I multiply these two signals, okay, starting from here, you start one by one. You start one by one. You know, what is the amplitude of the signal here? 1. 1 multiplied by 1/4, right? And then you add the summation mark telling you you have to add the product of the signals, plus 1 multiplied by 1/4. Then you have another one here, 1 multiplied by 1/4. Then you have another one here, 1 multiplied by 1/4. Then you have another one here, 1 plus 1, 1 multiplied by 1/4. Okay, then if you look, it's going to be 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4, right? So this means 5 times 1/4, isn't it?
Yeah.
Okay, so this is same as n plus 1, isn't it? When n is 4.
Oh, okay, sir.
So if you don't add 1, you are losing one of this if you don't add 1. So that's a short way of calculating. Instead of going to calculating one by one, you take the upper limit. Like in this case, the upper limit is 4. If you take the upper limit and then subtract the lower limit, let's say you take the upper limit, subtract the lower limit, you get 4, right? And then 4 multiplied by 1/4, isn't it? Right? For example, if you look at the signal, the upper limit is 0. Sorry, the upper limit is 4. And the lower limit is 0. Okay, and then you go and multiply by 1 plus 1/4. Then you get 1/4 multiplied by 4. But actually there are 5 of them. 1, 2, 3, 4, 5. There are 5 of them. You'll be losing count. There'll be counting error. That's why we add this one.
Okay, sir.
Okay, good question. You know, these questions all must be understood. Everybody see that?
Yes, sir.
JJ got a very good question. Some of you accept it. Oh, the lecturer said, okay, we take it. Don't be like this, you know, you have to investigate. Okay, now we continue to move. Now we are only midway, not midway. We are already having the overlapping part here. We have overlapped here, okay. Then you have to continue to move out, continue to slide through and move out. As you move out, you want to find out what is the output. Okay, so this is the output for this range. Okay, for the first time, I'm going to do this in detail. I mean, what I mean by detail is to show you graphically how it works. Subsequent times, you don't have to draw them again and again. You know, it will be wasting time, especially we are going to do in the exam. But you know, you can try to sketch it if you can't see it. So now you continue to slide through. Okay, now we continue to slide through. Now we already slide through. Now, where are you? Okay, yeah, at 4. So earlier on you were here, right? Okay, now you're going to slide until, okay, you are here like this. You're going to slide through until the end of the signal, because at k is 7, you have a non-zero signal. So you're going to try to slide and align the ends like this, where they are non-zero signals. Now, what is the range of k, n? What is the range? N is greater than upper limit of the n is determined by lower limit of the n. You can see the lower limit is right here. The lower limit
3.
is determined by this. Lower limit is
3, sir.
this is a limit for n. Okay, that's a problem here. Okay, I have a problem. Okay. Just give me a few seconds here. Okay, h of x of k. Actually, this is a limited. I'm sorry, I forgot. I apologize on this part here. This is a limited signal. It's not going up to infinity. Okay, the signal, as you can see, it's going in the negative direction, but it will be, okay, you can look here. What x of k is, let me h of k, for example, is 1/4 uk minus u k minus phi, right? So this signal, if you invert this signal, this signal h of k is just a signal that's going from 0, 0, 1, 2, 3, 0. UK minus 5 is how much?
5. Starting from 5, right, sir?
Yeah, 5. So 4 and 5, right? 5. Okay, this signal is not going to infinity like what I said, what we have drawn earlier. This signal is not going to infinity. So h minus k going from 0, 1, 2, 3, 4, 5. There's a mistake here. So
no. I mean 5 is k minus 5 if for hk is 0 until 4, correct already, sir?
okay, good. What do you know what Jintek is saying? Do you guys understand?
No,
Yes,
sir.
sir.
Okay, what
Yes, sir.
Jintek is saying, UK is like this from 0, 1, 2, 3, and going up to infinity, right? Then u k minus 5 is going to be
X up to
0,
5
2, 3, 4.
to 5.
So this is starting from 5. Okay. So if you subtract them, the signal only appears from
5.
this is what u this x sorry, this is h minus k. We just show you that hk is zero, 1, 2, 3, 4. Okay, you inverse it, then you get h minus k. So earlier on, I go and made a mistake. I put like this. I put an infinity, right? I put infinity sign, so which is wrong. So the signal is limited to -4. K is -4. Okay, guys. So please be careful when you draw this. You can make mistakes once you, yes?
K minus 5, am I right, sir?
Huh?
K minus 5, am I right?
K minus 5, where?
Yeah.
Like what?
K minus
K?
5, am I right?
This one
K,
h minus k. H
K minus 5.
h minus k is h minus k is just uk minus u n minus 5, k minus 5. Which one are you asking now?
No, just now you mentioned K minus 4 is K minus 5, is it?
Oh, you mean this? No, it's until -4. It's until -4. JJ?
Yes, sir. Okay, got it, sir. Okay, understood, sir.
You want me to do this again, then I will
No.
open a new page and do it. Who
No,
still
sir,
cannot see this?
Okay.
So then the annotation for the h minus k, right? For this one should be h n minus k, right? Because this is until -4 and the amplitude is 1/4, and according to above, we already do for the whole equation, right?
You are saying that this is n minus k. Hello? Hello?
Yes, sir. This one, just this circle just now you just draw right above this one, the annotation should be h n minus k, right? Because this
Okay, this is, I'm just drawing h of k. That's all.
okay.
Okay, h of k here is 1/4 u of k minus u k minus phi. Okay, I'm just drawing the h minus k. With h minus k, got all the information. Is that clear?
Yes, sir.
So now next you just adding n. So I just go and added n here. That's all. Plus n. When you add the n plus n, when you plus n, when you minus 4 plus n is same as n minus 4. Okay, everything is the same except that now I don't have the signal going to minus infinity. It's 0 after minus 4 and minus 4. So that's all that's all I wanted to say. If that is the case, then I have to change here also. If that is the case, then I'm going to change here also. Okay, it didn't really affect the first part. This is the first part. There we go. So this is the first part of the evaluation when there's no overlap. Okay, this is the second part of the evaluation when there's an overlap. I just put here 1. Sometimes for no overlap, you just can mention verbally. There's no overlap, therefore y of yn is 0. For the second part, you overlap until this end they are aligned. Okay. When this end is aligned, again here also I have to change this back. What a blunder I made, So early in the morning I was really sleepy. That's why you shouldn't sleep late. So when I align this end, right, so my lower limit is controlled by what? 0 or n minus 4? Your lower limit for k is controlled by 0 or n minus 4? Hello?
0.
Yeah, 0. Why 0? Because below 0 there are no signals. Below 0, yes, everything is 0. There's no point of putting n minus 4 as a lower limit. No matter what the value of n, below 0, the output is going to go to 0. So the upper limit, as you can see, the upper limit, although you are aligned with 4, but you cannot say upper limit is 4. Upper limit is determined by n. If your n is 5, well, then you're going to be aligning with 5. If n is 6, you're going to be aligning with 6. So the upper limit is controlled by n. Maximum n can go is 7. If n go above 7, right? If n, let's say if n plus 1, n plus 2, n plus 3 go above 7, the output is going to be 0. because above that there are zero signals here. So this is something intuitive. Okay, now let's look at the overlapping part. That's why this is important, because the signal is limited on the left side. For the next part, it's overlapping until the right hand side align to each other. So if you now, what will be the, you need to write the range of so what is your n is going to be for number part 3? Your n is less than what and greater than what? Greater than what or less than what? So similarly, what is your k? So these two, make sure you must write these two. What is the lower limit for n? Look at the one that is circled. I circled, right? Maybe
3,
it's not a
sir.
perfect. Huh? Lower limit
3, sir.
3. Okay, the lower limit of n okay, see, when n equal to 0, then you're right at the center, right? Then as you continue to increase n, 1, 2, 3, and so forth. Okay, at what value of n, you're going to get 3? Okay,
n minus 2.
okay, first one, you look at it carefully. First one, we are aligned here. So what was the limit for n? Clearly n, because when n equal to 0, when n equals to 4, n must be less than 4. And when n is equals to or less than 4, then you end up getting 0 here, right? See, right here. When n is 4, we get 0. When n is 4 here, if you put n equals to 4 all over the place, you get 1 here, and 2 here, 3 here, then n is 4 here. So that's how you get this limit. So now same thing you're going to do here. Okay, let's do. Okay, let me do step by step. So you can get some idea. I thought I'll do the end first. Maybe that's not a good idea. So let me go step by step. But this one problem is taking quite some time, but it's okay. If you can understand this one problem really well, okay, let's you were here right earlier. Okay, let's say you move one more step inside here. So if you continue to move step by step, you continue to move step by step until you come to 7. Any idea, guys?
N equal to less than 7, am I right, sir?
Yes, correct. Then more than
7, is it?
it's okay. No, we can do this, no problem. We can do this together. We can do this together because remember the last time we left off. Remember the last time the upper limit was 4, isn't it? So we're going to start from 5. So we're going to start n is greater than 5 or equals to 5, but less than 7. The upper limit is controlled by this. Sorry, I just wanted to make you guys think about this before I move on so that it will stick in your mind. So in this case, the upper limit, of course, is controlled by 7. After 7, there's no signal. But the lower limit, last time you only deal with until 4. So you're going to start from 5, right? So therefore, K is going to be the limit for K the limit of K in terms of n, because the n decide the maximum value. The n will decide the maximum value. If n is 4, then the upper limit is going to be 4. If n is 6, then it's going to be 6. So the upper limit is controlled by n. The lower limit is controlled by of course, you can see right here. This is k-axis, right? This is the lower. The lower limit depends on n minus 4. So n minus 4. Does this, guys, make sense to you guys? Think about this for a while. If you let me know if you have any confusion. Okay, sorry, okay, that's correct. Okay. So can I move on?
Yes, sir.
So the voice of, even though you are confused, but I'm also confused, but make sense out of it. So the lower limit for this convolution part is, yes?
Can we try to put in like n equal to 5, n equal to 6, n equal to 7 to see how?
Yeah, that's all. Of course, the n, this n is going to be 7 eventually. You also can put 7, no problem.
Okay, sir.
Okay, the lower limit is n minus 4. Now we putting everything in terms of n. So now here, you can, instead of putting n, I can just put 7, n equal to 7. Of course, n determines the upper limit, but the maximum that n can have is 7. So again, you're going to have 1 minus 1/4 is always 1/4. Okay. It's 1/4. So we just leave it as 1/4 there. And that's going to be 1/4 upper limit minus lower limit plus 1. That's going to be 1/4 for n is less than 7. N is less than 7 or greater than 5. Any question? We have one more. Number 4. Now I'm going to bring this over again so that you can see that Okay, you have to continue to move. So now you're going to continue to slide. You're going to continue to slide over until you overlap the left hand with the right hand. So you have to do the overlap. The reason why we have to do so many things is because one of the signal is long. I know it has 0, 1, 2, 3, 4, 5, 6, 7. The other one is short. So only 5 of them. So that's why we have to go stage by stage and do it. So the last stage will be when, of course, when n is greater than 0, there's no overlap. But the last stage is when you align this. You align this. Let me clean up a little bit here. Nine, 10, 11. 9, 10, 11. So when you align these things, when you align this here, on the other end, extends until the 11, and until k is 11. You're aligning with k is 7. You're aligning n minus 4, and k is 7 on the left side. On the other side, ended up aligning n with 11. So in this case, the k is going to be n. Your range for n is what is the range for n?
6 is it?
11 to
7 to
11.
11.
No matter what's the value of n, it must be 7, okay? Because beyond that is 0, okay? So the lower limit must be 7. The upper limit, where n is aligning with 11, so n must be 11. If n is 11, then this is 11, this is 10, this is 9, this is 8, and then this is 7, right?
Yes.
Therefore, k is in terms of n. K is in terms of n is the lower limit is n minus 4. And the upper limit, of course, you know, the 11 is the highest point you can see there. N minus 4, sorry, there's 7. 7 is the highest point because 11 is all, okay, so we'll forget. Above 7 is all 0 signals. So k is n minus 4 to
Okay. 7.
huh?
7.
Okay. Yes, but it may look silly, but that's how it works. Minus 4k is less than n minus 4, sorry, greater than n minus 4, but less than 7. Okay, this is just for understanding. What is most important is you have to be able to put the limit here when you evaluate it. Okay, this is like k is going to be going from, so this is the most important limit that you need to know. N minus 4, the lower limit is determined by n minus 4. If n minus 4 is greater than 7, then it's going to be 0 output. But if n minus 4 is less than 7 or 7, then you can evaluate this. So lower limit is n minus 4 right there, and the upper limit is 7. One minus 1/4 is always 1/4, so we just put 1/4. So what this convolution doing is taking the sum of product of two signals with one of the signal inversed and time shifted. You can just either do that, or you can just put 1/4, 1/4, then you do the same thing like what you did earlier, 1/4 7 minus upper limit minus lower limit plus 1. So that's going to be equals to 1/4 12 minus n, where the limit of n is less than 11, but it's less than 11, but greater than 7, right? If you want to put greater than 7, okay, roughly around there. What is more important is only this part is most important. Make sure you know the limit is not so important, but make sure you know how to do this, and make sure you know how to set this up like this. These are the most important things. So the most important thing here is this thing. Of course, this is, you cannot be doing this in real life. People have computers to do these things. We're just doing a small signal in image processing, DSP, digital signal processing. We want to be a DSP engineer. Things get more complicated. So this one problem, you have so many domain to evaluate. Some of them is kind of pretty straightforward. But usually in the midterm, I only give them very simple one, very simple. The last one is you want to mention for n is equal to greater than 0. If n is greater than 0, not greater than 0, but you don't have to worry about this. Once n minus 4 is greater than 7, there's going to be no overlap, right? Any question?
No, sir.
Okay, that is one of the rough problems. There are much easier ones. There are a lot more easier ones that you can do. But to get more practice, you can do. Kind of maybe the next problem. I'm just going to go through what I had earlier because I'm getting tired, myself. And then not only that, time is running out. Because the first one we did in detail, right? The subsequent ones, maybe I can take a little bit of shortcut. This notes is already available in the Google Classroom. So can we just go through this? Is it okay?
Yes, sir.
Yes, sir.
Okay. So we have two signals here. Let's say you have signal xn is un plus 2, and then xk, you change variable. Okay, you let n equals to k. Okay, another signal, you have n, hn, un minus 2. In this signal, you replace n with n minus k, or same as minus k plus n. So one of the signal, you just change the variable. In this signal, you just change the variable only. Sorry. This signal, you just change the variable. You just let n equals to k. But in this signal, you have let n equals to n minus k. That's all the difference. What this means is you have inversed the signal, and then you also have shifted the signal by n. Inverse and shifted. Then you take the sum of those products, which is shown in graphically now. So this is x of k. You know how to sketch x of k, right? By now, just a signal that is shifted, just a step signal, a discrete step signal that is shifted to the left by 2. Okay, and then you look at h of k, and then they show you step by step how to do it. h of k is u k minus 2. Okay, you can do this way. h of k, I'm just replacing the n with k minus 2, h of k. So it's just a signal. If h of k, it's going to be, if it's just h of k, it's h of k. If h of k is uk, okay. If you're just sketching use of k, so it's going to be just a signal that's starting at 0 and then going towards positive infinity. Now, when you have uk minus 2, you're just going to shift the signal to the right by 2. Okay. Okay, now you're going to add, you're going to plus n. H minus k plus n, that's different. Usually you will add n, the previous case. But in this case, plus n becomes minus n. So what you're doing here, because you're not, you haven't split. So in my previous case, okay, in this case, you add n. When you plus n, in this case, when you added an n, you also plus n here, plus n here, plus n here. You plus n after you are inverting the signal. Okay, in this case, it's not inverted. So if the signal is not inverted, plus n becomes minus n, just like a minus n, minus n, minus n, minus n, minus n, minus n. So that's how you get minus n. If you plus n, is same like subtract. That's how you get 2 minus n. So here is going to be 3 minus n, 4 minus n. Okay, after doing h, k plus n, after doing a k, h plus n, to get h minus k plus n, you just have to inverse the signal or flip that signal around. Actually, we don't know where 0 is. Just assuming if your 0 axis is somewhere here, let's say it's 0 here. Let's say we are flipping this around this axis. Then this arrow, which is pointing in this direction, now is going to point in this direction. And then 2 minus n becomes 2 minus n becomes n minus 2 right here. So this is another way to do it. So the first and foremost, you have to sketch them accurately. Once you have sketched them accurately, then you can take one of them and slide through. So now if you look here, xk is a signal that's going to infinity. Note very carefully, this is going to infinity, but this is all zeros. They're going to infinity, but they are zero here, zero. That means it's just like, you just can forget about this. It's zero until in the infinity, that's all it means. But this is non-zero. It's just one, and going up to infinity. So keep that in your mind. Make sure you know that when you're sliding through. So here is xk. This is xk. Redrawn here again. Now you take h minus k plus n and you slide through. Just sliding through this. So for n less than 0, which means k is less than minus 2. K is less than minus 2. Okay, so n is less than 0. When k is less than minus 2, k is less than minus 2, right? So n minus 2 so n minus 2 is less than minus 2. So n is less than 0. Okay, that's why when n is less than 0, there's no overlap. So yn is equal to 0. So when n is less than 0, your first, this point here, move to this point. It doesn't exist here. This is for n is less than 0. Okay. So now you start looking at for n is greater than 0. Are you guys okay?
Yes, sir.
For
Yes,
n is
sir.
greater than 0, okay, then you start to slide in. You're sliding in, you keep sliding in, and the important point to note here, when you keep sliding in, it's going up to infinity, right or not? You keep sliding in, so that means you're going to continue to slide to the right up to infinity. So for n is greater than 0, remove all these things, will be confusing you. For n is greater than 0, k is going to be greater than -2. The k limit, -2. Upper limit is n minus 2. Say we are sliding in, but you don't know where this value, it doesn't mean you're aligning with 2. It depends on the value of n. Okay, there's no relevancy because n minus 2 decides the upper limit. N can be 100,000. N can be 100,000. Then you're far to the right. In that case, the k also will follow that. So the upper limit is controlled by n minus 2. And the lower limit is controlled by this, because below this it's 0 signal. And above the n minus 2, this is 0 signal. So n minus 2 is a limit on the side, minus 2 is a limit on the other side. So that's what decides on the upper limit and lower limit. So one more time, okay, minus 2, the lower limit for k is decided by the xk signal. Xk signal, it's 0 everywhere below this. So this is the only signal. This is the beginning of non-zero signal. So that becomes a lower limit. The upper limit, okay, this is a non-zero signal going to infinity. This is going up to infinity, so that cannot determine your upper limit. But this one can determine your upper limit because the non-zero signal ended here, somewhere here. Then it's going to be 0 after this. So this is the highest value, which is n minus 2. And we don't know the numerical value. It depends on what the value of the n going to be. So that's how we decide the upper and lower limit. Get used to it. If you're confused, from problem to problem, it may differ slightly. Then to evaluate, you go from k minus 2, lower limit. This lower limit is fixed by xk. Below minus 2, 0 signal. And the upper limit is fixed by n minus 2. Because xk after a certain point is 0. So now both signals are amplitude 1. So 1 times 1 is 1. So that's why you're getting 1. So 1 times 1 is going to be 1, right? So that's why we have 1 here. Now next you take upper limit minus lower limit plus 1. Okay. The range of values for n. N is the lowest value for n is 0. The highest value for n, because n, is, you come and look here, n can be any value up to infinity. Can you tell for sure what the n value can be? We cannot tell what n is. So we say upper limit is infinity. Lower limit is 0. So even